esteemed colleagues, welcome to the 4th International Conference on Machine Learning, IoT and Big Data. Today, we embark on a journey of exploration, innovation, and collaboration in the ever-evolving realms of machine learning, IoT, and big data. As we gather here, we recognize the transformative power these technologies hold in reshaping industries, economies, and societies around the globe. And as we convene for the fourth time, we are going to delve even deeper, push boundaries further, and unlock new frontiers of knowledge and opportunity.
So, stimulating and
Before we proceed with the event, I request all the dignitaries to kindly come upon the stage and take their respective seats. I request Professor Dr. AVNL Sarma Sir, Vice Chancellor, GIT University, Professor Siba K. Udgata Sir, University of Hyderabad, Professor Dr. Ellen Patnaik Sir, Adjunct Professor and NASI Senior Scientist, Indian Institute of Advanced Studies, Bangalore, Professor Shreepad Karmalkar Sir, Director, IIT Bhubaneswar, Dr. Kakita Mulli Gopal Sir, Deputy Dean, Computational Science, GIT University.
we are on it.
Hello.
Start na?
Start karo.
या कुन्देन्दु तुषार या शुभ्र या वीणाभरणमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करा दिवे देवैः सदा वन्दिता सा मातु सरस्वती भगवती निःशेषजाड्यापहा.
We have with us an academician, a beloved teacher, and a focused leader with a vision to improve the overall development of the university to the international standards. We have among us a personality who, with his leadership, provides the direction, coordination, and assessment of academic unit as a whole. May I request Dr. AVNL Sarma sir, the Vice Chancellor of GIET University, Gunupur, we would be honored if you join us to deliver the welcome address, sir. Your presence and words would greatly enhance the event. Please, sir.
Thank you, dear. So, good evening to one and all. On behalf of our Honorable President, Sir, Dr. Satyaprakash Pandaji, our Vice President, Dr. Chandradhwaj Pandaji, our Director General, Jagadish Pandaji, our Pro Chancellor, Dr. Ellen Patnaik ji, and our Registrar, Dr. N.V. Jagannath Rao ji, and distinguished subject experts, professors, deans, faculty, and my dear students. I extend a warm welcome to our chief guest, Professor Shreepad Karmalkar, Director, IIT Bhubaneswar, to this fourth international conference on IoT ICIMB 2024. Sir, our institution is sponsored by Vidya Bharati Educational Trust, GIET, and it was established in the year 1997 with the 4 UG programs with a total intake of 200 students. Now, it offers 17 UG engineering programs with a total intake of 1,140 students and 14 PG engineering programs, including MBA and MCA, with a total intake of 456. Before university, our programs are 50% NBA accredited and 2 cycles of NAC accreditation with 3.28 CGPA. 2 of our programs were NBA accredited under Tier 1 since we are university, and we are in the process of acquiring NAC and other standard quality markings. So it is my pleasure to highlight a few facts on today's theme, the big machine learning in practice and its implications for today's business. That is the objective of this fourth international conference, ICIMB 2024, jointly organized by Department of CSE, GIETU, and Springer. In the I thought, as you know, what to say. I have I computers and today. I cannot believe how industry will be like if we were to go to the end to generate and punch colors process data. We have to together with all stakeholders, academia, startups, and industry practitioners to build a which have the necessary data, tools, infrastructure, and skill sets to facilitate the use of data to gain new insights, improve decision making, and make the industry well placed for the digital economy of the future. Is persistently transforming from the internet of computers to the internet of interconnected systems, also known as cyber systems, are emerging from the accumulation of many facts like infrastructure, embedded devices, smart humans, and a physical environment. This has been to huge internet, smart server, physical earth. IoT and the CPU conjugated with the data science may bring our next smart evolution. The country is to have a huge data set with the much weaker existing computation power. The research in data intelligence has been striving to give a this product. But I huge breakthrough. This is not saving money, smart things reducing human effort or this is much more than existing human life. There are some serious issues like the security concerns and the ethical issues which will go on IoT. The big picture is now how fascinating IoT with AI skills, but how principle or people perceive it. Is it a book, a button, and the point here is that I think happen when we instead of resisting change, let us embrace it and do what and must do to be prepared for just that life technical machine but there will be no cost. In fact, I wish people will continue to think putting data science into context. We will still be able to output of the complex machine learning algorithms and interpret the results. This actually means and what implications are done for decision and policy making. There are many stakeholders and in our collective responsibility to seek out the opportunities in this revolution and not only of disruption, but to facilitate the transition of the culture. Let us embrace these changes with open heart and minds and work together to our data science journey to create wealth for the economy and at the industry, corporate, and individual levels. So, thank you all for giving me this opportunity. Thank you.
Thank you.
Without further ado, it is my distinct honor and privilege to introduce our keynote speaker, Professor Siba K. Udgata sir, from School of Computer and the Information Sciences, University of Hyderabad, an esteemed figure renowned for his extensive experience and unwavering positivity and realm of technology and innovation. With a diverse portfolio of projects, including Wise Home and Health Craft, he has demonstrated a remarkable ability to leverage technology for societal benefits. Professor Udgata's contributions extend beyond project works, his prolific publications, patents, and journals exemplified by recent works such as machine learning models for IoT edge devices based water quality monitoring showcase his dedication to advancing knowledge. Whose unparalleled, please join us in extending a warm welcome to our keynote speaker, whose unparalleled expertise and visionary leadership will undoubtedly enrich our proceedings and set the stage for an unforgettable experience. Please, sir.
Thank you. I'm here as a TPC chair, not as a keynote speaker. Of course, I also delivered a keynote talk. Respected Professor L.M. Patnaik, the General Chair of this conference, and distinguished Professor at NIAS, Bangalore, Professor Shreepad Karmalkar, Director, IIT Bhubaneswar, the Chief Guest of today's function, Professor Avian Sharma Garu, the Vice Chancellor of GIET University, Professor Murli Gopal, the Dean of Computational Sciences, Dr. N.V.J. Rao Garu, the Registrar of this university, Professor Raghavendra, the organizing chair of this conference. There are other, my fellow TPC co-chair, Professor Srinivas Sethi from IGIT Sarang. And my friends from GIT University, colleagues from different NITs, IITs, etc. So a very good afternoon to all of you actually. So I'm pleased to be here, and I'm pleased to be here and standing before you at the Technical Program Committee Chair. And I extend a warm welcome to all of you. On behalf of my team, I'm one of the program co-chairs. My other co-chair is Professor George Ghinia. He works in Brunel University, UK, and Professor Srinivas Sethi from IGIT Sarang. So it's really a pleasure to be part of this much awaited inaugural function. We have been waiting for this for quite some time. And then for this 4th International Conference on Machine Learning, Internet of Things and Big Data that is being organized by the prestigious Gandhi Institute of Engineering and Technology University, that's known as GIET University, and at Gunupur, Odisha. So in this situation, right, we know that where Gunupur is, how remote it is, how difficult it is, and organizing such an international conference, it throws much a challenge, and the organizing team, organizing committee rise up to the expectation and could organize it wonderfully. So thanks to all of them actually. So we have a plethora of keynote talks, tutorial talks, technical talks, workshops, poster presentations, not poster presentations, project presentations, etc. So the conference draws some of the excellent technical talks, research papers. 2 tutorial talks were organized yesterday by Dr. Sibaram Paningre from NIT Rourkela and Professor Srinivas Sethi from IGIT Sarang, were held yesterday. The overwhelming response of these tutorial talks is really worth mentioning here. Almost 200 people, 200 participants registered for that. It was also streamed in the YouTube yesterday. And I was told that there are more than 100, 200 people who participate in that also. So apart from the tutorial sessions, we have planned around 8 keynote talks, one by Professor Rammohan Mallipeddi. He traveled all the way from South Korea to Gunupur and only to attend this conference and then deliver this talk, and big thank you to him also. Then Professor Alok Singh, one of my distinguished colleagues from University of Hyderabad. We also have Professor Yupai Usawa. She will be delivering, she is the International Director at Sonari University of Technology at Thailand. She will be delivering the talk tomorrow. Then Professor Rajeev Kanth from University of Taku is in Finland. He will be delivering tomorrow also, and they are all planned. We also have an industry track actually, and 2 distinguished industrial professionals. I think Dr. Vipul Vashisht, the CEO of Logazon Technologies, are going. He has already delivered the talk in the morning. And tomorrow we have Mr. Sandeep Konar. He will be traveling from Hyderabad. He is the CEO of A-Bright Technologies, and which is a leading healthcare company at United States. So he is the CEO and co-founder of that. And we look forward to their talks actually. So we are grateful to all these speakers who spared their time, came all the way to Gunupur with all possible means, train, air, bus, car, taxi, and all these possible things. So I planned some innovative project showcase event, and I can say that many of the student projects have been showcased yesterday here, and I was not here, but I was told that the project showcase, some of the project showcases are actually pretty good, and they are quite amazing actually. So thanks the students for coming out and showcasing your projects, etc. So any conference is incomplete without the research contributions of the distinguished researchers. We received 368, I repeat, 368 research papers, research full papers actually submissions, and we could accept only 78 papers with an acceptance rate of around 20%. And 20% of acceptance rate is, I think it's pretty good in any standards. And this, we have to do this unpleasant task of receiving only 20% and rejecting almost 80% of the papers, keeping the standard of the conferences, the guidance and the advisory of Professor L.M. Patnaik, the General Chair, and the strict provisions and the guidelines of the Springer Publication House, which will be going to publish the Springer proceedings here. So each paper has been reviewed by at least 3 independent reviewers, and in many cases we have also 4 and 5. And all these papers are reviewed. We have done the similarity score check, plagiarism check, and all these papers. I repeat, actually they are all less than 20% similarity score and plagiarism score. Although personally I don't believe in those plagiarism and similarity score, but I still believe in that it has to be done keeping the integrity of the papers in the conference and other things. So I must thank all these reviewers. We have more than 300 reviewers who have done this job. So we must thank from this podium that all the reviewers have done an excellent job. They have done it in real time. They have done that in the kind of very rigorously and meticulously, and it's a tremendous job actually. So let us thank all the reviewers for their commendable job. So on behalf of the technical committee, we are indebted to Professor L.M. Patnaik, the general chair of this conference, for his timely and valuable advice. We cannot imagine this conference without his active support at all the crossroads of the decision-making process. The management of the host institute, GIET University, have extended all possible support. In fact, I think they have gone beyond the possible supports and for to conduct this conference. And our sincere thanks from the technical committee, our sincere thanks to the organizing committee and the management of the GIET University. We'd also like to place on record our thanks to all the keynote speakers, tutorial speakers, reviewers, session chairs, authors, technical program committee members, various chairs to handle the finance, transport, accommodation, hospitality, publications, publicity, and above all to the volunteers, right? I mean, they have done a wonderful job actually. So we are also thankful to the Springer Nature Publication House for agreeing to publish the accepted papers and presented the accepted papers in this conference to publish in their upcoming volume in the LNS series. I think the organizing committee made all the arrangements to make the delegates, the authors of this conference enjoyable and a good learning experience for everybody. Hope all the delegates attending the session, both in person and virtually, will enjoy the presentation and also use the opportunity to exchange their ideas and do some further research on that. So please take care of yourself, your loved ones, and stay safe. Thank you very much.
Professor Dr. L.M. Patnaik, sir, is a distinguished academician in computer science and engineering, having earned his PhD and DSc from Indian Institute of Science, Bangalore, with over 50 years of experience. He has made notable contributions to high-performance computing, mobile computing, AI, and machine learning. His extensive publication record includes over 1,300 publications and numerous doctoral and master theses supervised throughout his career. Professor L.M. Patnaik, sir, has received prestigious awards like the Dr. Vikram Sarabhai Research Award and the IEEE Medal of Honor. He is a fellow of esteemed academies, including IEEE, TWAS, and the Indian National Science Academy. In addition to his research, Professor Patnaik has played a key role in enhancing technical education in India, initiating programs in cybersecurity and nanotechnology. His global impact is evident through invited lectures and engagement worldwide, showcasing his significant contributions to the academic and research community. May I request our Honorable Dr. L.M. Patnaik, sir, to please come and share some useful insights and address the gathering. Please, sir.
Good afternoon. Distinguished chief guest of this inaugural function, Director of IIT Bhubaneswar, Professor Shreepad Karmalkar, the President, Professor Panda in absentia, Vice Chancellor, Professor Sharma, then we have the Deputy Dean, Professor Murali, Professor Udgata, one of the key players for this conference as PC co-chair. We have the registrar, Professor Rao, other deans, heads of the departments, faculty members, young student friends, the delegates who are attending, and the keynote speakers, invited speakers, tutorial speakers. I see several others who have contributed to the conference. Professor Srinivas Sethi, Professor Raghavendra, Professor Sendas. There are several of them who have played a key role in organizing the conference and getting the papers reviewed. As I always keep telling, organizing a conference in India is something like organizing a marriage ceremony. Whatever you do, there is bound to be some problem, whether in terms of transport, food, organizing sessions. It is a challenging and tough task. And organizing an event like this in a remote place like Gunupur is still more challenging. I am particularly grateful as the General Chair. In fact, I am wearing two hats as the Pro-Chancellor of the University and as the General Chair of the conference. I am grateful to the chief guest of this evening, Professor Karmalkar, who, in spite of his very busy professional and personal schedules, could find time to travel by road all the way from Bhubaneswar for this function, and he is again getting back immediately after this function to fulfill his commitments. In fact, several weeks ago, when I took the liberty of calling him, he was very kind enough to agree, and he said, we need to fix a date. He has fulfilled his commitment. So we are really honored to have you, sir. I would like to extend a warm welcome, as I said, as the Pro-Chancellor of the University, as the General Chair of the conference, to all the delegates, students, and all the dignitaries. This conference has been, I think, a successful event for the last 3 years. This is the fourth one. The objective has been to take it to smaller places where students and faculty members do not have an opportunity to get exposed to latest things in technology. So in that respect, we are grateful to the reviewers, authors, keynote speakers, invited speakers, session chairs who have taken the trouble to come all the way and participate in the conference and share their knowledge. The theme of the conference is quite topical, interesting. It addresses machine learning, IoT, and big data. But I am not going to talk too much on this because, you know, in a profession like IT, your popularity in the profession is inversely proportional to your age. So I have the distinction of being the senior most among the audience, born before the independence. So obviously, my exposure to topics in IT and my demand in IT is minimal. It is young faculty members, young students who can share their knowledge, and we have a very distinguished chief guest who has made outstanding contributions to semiconductor technology in this country. He will share his ideas. Nevertheless, I would just like to touch upon few brief items. So recent times, as all of you know, AI has been a sort of a buzzword, but I think that is slowly getting replaced by terms like LLMs, large language models, and ChatGPT and whatnot. No one is talking about AI anymore. You hear these terms often. If you look at the general advancements in technology, different areas, some of us make a very casual statement. Life was so easy when Apple and BlackBerry were just fruits. So we started having problems when they took different shape. The global machine learning market is likely to reach something like $117 billion by the end of 2027. There is tremendous amount of demand on this. We talk about several algorithms we have seen during COVID time. 39% of the diagnosis was done by deep learning algorithms, 37% by other machine learning algorithms, 20% of the COVID-19, 24% was done by maths and statistics. So technology, in particular machine learning, software, computing, high-performance computing, play a major role. If these concepts didn't come to our rescue, I'm not sure whether we would have been alive today. The vaccine came into picture thanks to the advances in these areas. People studied what happened in MERS, SARS, H1N1, and could look at the molecular structure, protein structure, binding, and all that. Using machine learning algorithms, classification, came up with the vaccine pretty fast, which should have taken probably decades. So technology, particularly machine learning, has come into our help in many ways. So when we talk about trends in machine learning, these days we talk about unsupervised learning and no-code machine learning, then data automated machine learning, tiny ML, so that you can run these programs on microcontrollers and smaller machines. How do you miniaturize these things? The that is data ML model platform is to achieve efficient and economic scale. There were talk about cyber physical systems. We have been watching advances in Industry 4.0. You started initially with mechanization, then talked about electricity, mass production, and computers came in the third generation. Now the cyber physical systems, AI, ML, making inroads into industry. You have the entire industrial automation control being taken over by AI, ML, IoT, all these techniques. Everything is going to play an important role, including 5G, semiconductor technology, faster chips, whatnot. The contributions of AI, particularly in COVID-19 time, what we witnessed, warnings and alerts, tracking and prediction, data dashboard, diagnosis and prognosis, treatments and cures, social control. And social contacts, one could find out this using QR codes, image processing, vision, and number of techniques. So as I was mentioning, majority of the job in prediction was done by deep learning, then other machine learning algorithms, and statistical analysis. In recent times, we have been listening quite a bit about ChatGPT, fake news, and all that thing, fake tests. Okay. So, study ChatGPT generated abstracts sailed through the plagiarism check. This is becoming really frightening now. You talk about several of these software modules, concepts being used extensively in training, teaching, then probably even coding. So the question is, what is the role of computer science teachers and computer science professors? What should be the syllabi? What should be taught to students? As I mentioned, most of the computer science students, the graduates are recruited or employed to write code. So if the code writing is taken over by something like Codex, then Copilot, GitHub, and some of these things, what does a programmer do? And what do we teach in a classroom? So that is why computer science professors, teachers across the world are asking a fundamental question: what should be the future of CS teaching? What should be done? Of course, there are already textbooks which have started coming. Earlier, people used to write textbooks on Python programming, JavaScript, and all that thing. Now you find titles like Python programming with LLM, like large language models. If you integrate both of them, how do you teach programming concepts and teach the students? ChatGPT has made inroads even into some of the challenging programming tasks. Expert professional programmers visit the Stack Overflow even to get advice to solve tough problems. It has messed up and created confusion there, where you have something like almost 30 million question answers you find, and the technology which was developed over these years, more than 2 decades, you find that it is facing some challenge. So according to the market research claims, the amount of data that is coming, that will come in future from companies, government and individuals in the next few years will be twice as that we have got till now from the beginning of the computer age. So that's why we have topics like big data assuming great significance, because data alone is not important. All of us know you need to get some conclusions, some inferences. So you need some graphical tools, some machine learning algorithms, and some decision capabilities using this data. AI has been also growing at a phenomenal rate. If you look at our country, government very recently has initiated two very interesting initiatives. One is in the area of AI, second one is in the area of semiconductors. You will see tremendous amount of activities in these areas. They are talking about something like several thousands of GPUs put together, because machine learning algorithms are hungry for competition. You need faster machines. They are talking about parallel machines using GPUs, and how you could develop faster processor chips for executing these machine learning algorithms, where semiconductor industries, chip designers also will play a major role. On an average, recently, there was a study which was conducted by Microsoft. They called it Microsoft Tour. They said there are about 100 AI startups every day that are coming up in the country. And if you look at the rate at which AI developers and researchers are coming out, every sixth AI developer or researcher in the world is in India. And if you look at the rate of increase of the workforce, growth of workforce, the incremental increase, 25% of them will be from India. So there is phenomenal interest even in this country. And this was concluded by Microsoft in a recent study called Microsoft Tour, presented in Bangalore. Launched in 2023, Copilot in Windows empower us to create faster, complete tasks with ease and which lessen cognitive load. Organizations in India are seeing an average of $3.86 return for every US dollar spent on AI projects, and there are some 150 organizations which are already getting involved in projects using Azure Open AI in domains like agriculture, aviation, none of them. ChatGPT 3.5, as you know, uses something like 175 billion parameters. You talk about 3.5, 4, whatnot. There are ways to talk about algorithms, but during training, the amount of energy they consume is tremendous. By using a simple relation in the amount of energy consumed, the kilowatt hours or megawatt hours, to the carbon footprint, how many tons of carbon are generated, it is tremendous. So this is one of the negative points. That's why people say these algorithms are called red machine learning algorithms. So the research is now driven towards green machine learning algorithms, where the energy consumption has to be low by using some compression techniques. There are a number of techniques which are coming up to address this issue, where energy consumption is very important, because we talk about sustainability, carbon footprint and all that on one side, but these algorithms for training consume tremendous amount of energy. So the used in this is a tremendous 175 billion, and they use something like 570 GB of data obtained from books, web text, Wikipedia and all that thing, spreading over 200 billion words. And the technique used, you talk about simply something like what is the probability that it will hit upon, it will get the next word in a probabilistic way, calculation, rather than what Google search good old day did by looking at corpora. So there are interesting things happening, particularly in AI. But the main concern problem, as I told you, if you have these tools, these techniques, which could develop programs, take natural language as the input and come up with programs. And these programs, there have been found out number of the professors are working abroad in US and Canada and even Europe on the impact of these things in programming. They say first level programming course, they all pass. They do wonderful. They have conducted an exam taking something like 71 students. ChatGPT, the course generated from natural language, it had a rank of 17. So it came in the first quarter. So it cleared them. The marks it secured was 78%. So now the question comes, what do teachers do? How do you detect whether the program is written by student or some of these tools? So this is what CS professors and CS teachers have to respond in future. Further about industry will be happy if they can have less programmers, less coders to do that. The majority of the students get into coding. So if you talk about GIT, you talk about Codex, you talk about Copilot, you talk about some of these things, if they will replace the programmer, what is going to happen? There is a mention of risks in AI. It can't explain what it is doing. That's why we are talking about XAI or explainable AI. There are issues of ethics, like if there is a driverless car, it sees a pedestrian in front. Should it hit the pedestrian and go, or the people sitting inside should meet with an accident? So there are a number of these problems like trustworthiness, loss of employment was mentioned. Of course, the solaces people say you will get different type of job, but then one has to really witness that. That's why what happened 2 months ago, certain people like Elon Musk, Steve Wozniak, and Most Valley, who was former president of ACM, they all went to leading AI researchers for 6 months. For heaven's sake, stop AI research and experimentation. So that's what and from it slowed down the progress from GPT-4 to GPT-5. So without concern that things go at this rate, what's in store in future? That's interesting discussions you find. You have a book by Max Tegmark, who is a professor in MIT in physics and AI and machine learning. He has written a book, Life 1.0, 2.0, 3.0. Life 3.0 is worth reading. It tells you how to live in artificial intelligence. What are the problems? How do you address these issues? Number of interesting issues are discussed in this. We did talk about impact in education. Of course, the advantage of personalized learning, automated grading assessment, intelligent tutoring, and increased access to education, predictive analysis, number of things. But there are attendant problems also. You see, it is widespread. Now, Khan Academy is trying to get into Indian languages. They want to spread, then get this. Most of us referred, you know, excellent tips from that. Internet, there is a talk of, we saw IoT, then you have IIoT, Industrial Internet of Things. There is Internet of Drones, IoT, you talk about Internet of Everything. Now there is a talk of Internet of Medical Things, IOMT, how you can connect them. So if you look at the coding activity, it has been found out that in the neighborhood of 2.8 trillion lines of code has been written during the last 2 decades. So the major activity in computer science, software engineering is writing code. So my question area was, if that is going to be automated, it is going to be done by a machine, what do we do? What is the role of students graduating? What will programmers do? So this needs a serious thought. Fortunately, people who look at CS programs, curriculum, are addressing this issue, how the curriculum should be changed. Because we have things like ChatGPT, GPT-4, Amazon has talked about Code Whisperer, Google talks about Alpha Code and Bio, and you have GitHub coming up with Copilot for integrated development environments, which could be for visual programming studies and all. There are lots of these things, and if you look at the advancements, they could generate programs in Python, Perl, Ruby, PHP, the JavaScript, Java, anything you talk about. This has been one of the important concerns during COVID, 2 areas which really got into a challenge, and we witnessed a lot of advancements are in medical, healthcare, and the second one is in education. Education, we witnessed online education and all that. Healthcare, there are a lot of advancements happen. People realize that only a close collaboration, interaction between engineers and doctors, you are scientists and doctors, you can see exciting things happening. That's what I find even in India, most of the IITs, elite institutions, including IISc, have started medical schools in their campus. IISc, which is a traditional institute, now we are going to have a research medical school. I'm told IIT Bhubaneswar is joining hands with AIMS Bhubaneswar. And IIT Kharagpur has something in their campus. Delhi, Guwahati, all of them are talking about that. That is how to embrace doctors into their campus, do something useful, develop using AI, ML algorithms, mechanical engineering and stuff like that. This breed of scientists are called physician scientists. Doctors dabbling with science, engineering. Hope is that they will register for PhDs, do some exciting work. Incidentally, if you look at the list of Nobel Prize winners, 37% of the Nobel Prize winners belong to this class. They are physician scientists. They are doctors who are exceedingly well, are interacted and used extensively science, engineering tools like this. So the future will be more and more towards that. And the present world, there is a demographic translation characterized by low fertility, aging population, triggered by longevity gains by progress in medicine. So you will see more and more of aged people, people above 65, above 70. So obviously, the adults will take care of them, should have empathy, and you need to talk about some special tools, techniques, and software to take care of this elderly generation, because the numbers are going to be more. The share of the global population equal to 65 and above, which was about 9.3% in 22, will go to 16% in 2050. It is going to increase. Well, talking about IoT, the challenging issues in IoT is something about security. Okay, because you use heterogeneous devices. Suppose you have a driverless car, or there is an implant, something is implanted, there is a pacemaker in a patient, someone tries to hack that and accelerate, the patient will die. So security is going to be very concerned. That's why we find wherever internet has gone, we seem to have invited trouble. So IoT, people joke sometimes, it is not Internet of Things, it is Internet of Trouble. You have something because of use of heterogeneous devices not complying with standards. So standard security will play a major role when the IoT devices are projected to nearly triple, that is go to 29 billion in 2030. So semiconductors, nanotechnology, electronics and all will play a major role. Well, we're hearing about the great credits or discredits made in the area of fake news, fake images, and all that. This attracted the attention of the best of the Nobel Prize winners in May 2023. They had a meeting called Truth, Trust, and Hope, because they say people are losing faith in science because of all these fake news, fake images, thanks to AI, which detects that. So how do you address these issues, which is very in future some interest in these things. So looking at the advancements in IT, the CEO said IT is not information technology anymore, it is called intelligent transformation. So you find intelligence everywhere coming into picture. But examples, you might have seen the negative impact of fake news, fake images, like how Barack Obama was portrayed in a TV show making some nasty comments about Trump, but it was found out that it was actor comedian Jordan Peele. It was done by a GAN and it was detected by a GAN. They found that the lip movements were not of Obama. So issues and problems we find out thanks to AI. So the challenges are many, as we said, bias, expressibility, then inability to do math, not the issues. If you look at the energy consumption, as I was telling you, GPT-3 with 175 billion parameters consumes something like 1,287 megawatt of electricity and results in carbon emission of 502 metric tons, which is equivalent to driving 112 gasoline-powered cars for 1 year. So the energy consumption is tremendous. So people are concerned about that, what these algorithms will have. So other than this, as I was mentioning, particularly for computer science curricula students, one of the things which will be of interest linked to this is chip design and semiconductor design. The country is getting into this in a big way. Please understand that this is not the cup of tea of electronics engineers. You start from high-level specification, get into placement, routing, circuit simulation, logic simulation. There is enough of computer science. And a single chip design takes several hundreds and thousands of hours. It is a tremendous effort. There are CS algorithms and all architecture. With the interest in chip design in the country, I think the curriculum in CS also should undergo some change. We should shake hands with electronics and semiconductor people. That's what I wanted to talk about. Thank you very much. Wish you all the best. I would once again like to thank the management, the Vice Chancellor, Registrar, Deans, faculty for wholeheartedly cooperated to organize this conference, and in particular to Professor Karmalkar, who has added a different touch to this evening's event. He could be with us in spite of his toughest of the schedules. Wish you all the best. Have great fun and enjoy during the conference.
Thank you, sir, for your inspiration and valuable words at ICMIB 2024 as General Chair. Your dedication, support, and approachability created a welcoming atmosphere. We are grateful for your invaluable contribution to our community, sir.
Solutions. Maintenance. So, a complete
Hello. 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 Hello.
Hello. Hello. Yeah. Am I audible? Hello. Hello. So first, I want to say that I'm very happy to come to your college. I have come to Odisha just more than a year ago, and I'm happy to explore the educational institutions in the state. Otherwise, before that, I was at IIT Madras for almost 40 years. And I'm very happy to see that Odisha has a lot of educational institutions, something I was not aware of. So it is a learning experience for me. Now, sitting through talks is not very enjoyable all the time, particularly in the afternoon after lunch. So how do you think you can stay awake during a talk? Can someone tell me how do you do it? How do you manage to stay awake? You're all students. I was a student at one time. So one way to stay awake is to be engaged. So we will have an interaction, not a speech. But interaction depends on response from you. So let me start by first trying to understand your institution. It is like know your institution, right? So I'm going to tell you some data about IIT Bhubaneswar, and you should tell me the same number in your university. Let's start by talking about the area of the institution. IIT Bhubaneswar area is about 4 square kilometers campus. Can someone tell me what is the area of your institution? Anyone has to just stand up and tell. What is the area of your institution? If you want to tell me in some other units, that is also fine. Can someone tell me normally land area, what is the unit used? Yeah, you are right, acres. So tell me in acres, how much is your area? 100? 100? 133, okay, 130 acres. So now let's get a feel of these acres. I told you IIT Bhubaneswar is about 4 square kilometers. How many acres do you think it is? Somebody is telling the right number. 900? 900 something, as you said rightly. About 1,000 acres. So that is the area of IIT Bhubaneswar. So your area is about 130 acres. Next, number of students. IIT Bhubaneswar has about 3,000 students. How many students does your university have? Okay. 5,000? Four, huh? More. Okay, 6,000? 10,000? How can 10,000 students be there in 130 acres? Come on. Okay. Okay, calm down. So IIT Bhubaneswar, there are about 200 faculty at this time. How many faculty do you have? How many faculty? How many? Anyone? Someone can tell. I think I should ask here because all the responses I get from here, those numbers. Huh? How many faculty here? Sorry? 300. Okay, you have around 300 faculty. Okay? Right. Okay, just one more number. Just one more number I need. Okay. What is the budget or annual budget of your institution? Okay. Now, so these are some of the things you should know about your institution if you want to talk about this, talk about your institution to others. Okay. Fine. So with that interaction now, let's get into the topic. So I'm going to talk to you about what is the uniqueness and evolution of semiconductor technology. I'm assuming that you all do not know anything about semiconductor technology. So I'm going to address non-specialists. How many of you know the importance of communication skills in life? How many of you know importance of communication skills in life? Just raise your hands if you feel communication skill is important. Raise your hand. So now you should tell me, when do you say you have communication skill? You have good communication skills. How do you decide? Can someone just stand up and tell me, when can you say, when can you claim that you have good communication skill? Anyone? Okay, so let me answer that question for you, because you are telling? Good. Tell me.
I am standing here and interacting with you, so I believe I have great communication skills.
No. So standing and interaction alone is sufficient. Everybody can stand.
So
Right?
having with the proper context, where should we speak what?
So she's telling one more thing. You should know where to speak what. It's a good point. I will give you another simple definition of good communication. You can claim to have good communication skill if you can explain your topic or your research topic. If you can explain your research ideas to your grandmother. Please remember, you can claim to have good communication skill if you can explain your research ideas to your grandmother. Okay, remember this. So if you, many of you have raised your hand, if you are really serious about it, right, you must spend time in doing this. It will help you in life. If you can explain your research ideas to your grandmother, then you can claim to have good communication skill. It has been found that people who rise up in society in various positions, they have this ability. Okay, so now I am going to try to do the same. Can I explain about uniqueness and evolution of semiconductor technology to grandmother? Right? Let's see. Here, of course, I have computer science students, not grandmothers. Now, 15 December 2021, there was a major news item. Cabinet approves rupees 76,000 crore for the development of semiconductors and display manufacturing ecosystem in India. Incentives of rupees 2.3 trillion to position India as global hub for electronics manufacturing. About 2 weeks ago, the Prime Minister inaugurated 3 major fabs. What was the worth of these fabs? Anyone can tell me in numbers, in rupees or crores of rupees? What was the worth? It was in news that the Prime Minister has inaugurated 3 semiconductor fabs. Anyone can tell? Close to 14? 1 lakh, more than 1 lakh crores. More than 1 lakh crores. So when India is taking this kind of a step, it is very important that the students, independent of the discipline, are aware of why is India investing in this area. Right? Why is India investing in the area? In our own Odisha, you have another news item here. Odisha continues to attract global semiconductor firms. RIR Power Electronics Limited's proposal to invest 510 crores approved, and so on. So even in Odisha, semiconductor manufacturing is set to become an important activity. So let us try to understand this over the course of next half an hour or so. Professor Patnaik talked to you about IoT, machine learning, big data, and all that. In terms of levels of technology, if we are talking, in terms of levels of technology, you can identify 3 levels of technology broadly: software, systems, and components. So what previous speakers were talking about is software level. What is an example of systems level technology? If somebody asks you, give us an example of an achievement in systems level technology. Anybody can tell me? Based on our recent experience. Achievement of India in systems level technology. Somebody asks you, what example will you give? Anyone? Yeah. Huh? Yes. India launched something on the moon. What was it? That's an example of systems level technology, right? Satellite is a system. Okay. Building supercomputer. Supercomputer is a system. So that is systems level technology. So here I have put the capability index. For software, excellent. India exports software, everybody knows. Systems, we can say good. It's moving towards very good, right? With launch of the satellite and so on. But in the components level, we are unsatisfactory. So if you talk about the system like a satellite, if you look at all the components which go into the system, then many of the critical components are still being imported. Okay? So in components level, we are not doing well. And what is the reason? Because this components level technology, it is materials oriented technology. It deals with materials. And in the area of materials, India has to improve. So materials level technologies, we are not doing well. Systems level, we are doing well. Software level, we are doing very well. But all these are based on components. If you don't have components, you can't build systems. If you don't have a system, you don't have computer, where is the machine learning? Okay? So that is why we need to talk about components. Unless we are good at component level, we cannot claim to have real independence. Okay? We are dependent on others. So that is the background in which I'm going to talk about semiconductor technology. It is a materials-oriented technology. What are other materials technologies? Steel, material technology, glass, another example of material-oriented technology, right? So like that, semiconductors. So what is unique about semiconductors? So I'm going to talk about 5 points. That semiconductor technology is materials-oriented, reasonably good high technology. It requires stringent processing conditions. Its products are easy to use, reliable, and high performing. Its training involves abstract theory and interdisciplinary topics. It has evolved due to 3 kinds of people who are not all identical: scientists, engineers, and inventors. Okay, so these are the points I'm going to expand upon, right? And periodically I will pause just to see if anybody has any question. How many of you ask questions in the class? Please raise your hands. How many of you ask questions in the class? I see some hands going up. How many of you don't wait for the teacher to give you a chance, right? You don't wait until the teacher says, kids, do you have any doubts? Even before that, whenever you get a doubt, you raise your hand and ask. How many are like that? Okay, so I will pause here and let's see whether you have any question. Some of you have raised hand, so now I am giving a chance. Any question so far? So periodically I'm going to stop in my talk and I'm going to ask you. But I will in fact be very happy. I'll go with a very good image of your institution if any of you raise your hand on your own whenever you get a doubt, to either ask a question or make a comment. Okay? Right. So let's start with this. What are the unique features of this technology? So let's start by defining technology. What is technology? What is technology? So technology is nothing but processing of either material or energy or information you process to get a useful product. This is what is technology. Okay? When do you call a technology as high technology? If the processing conditions are stringent, and as a consequence, you get a product that has high reliability and performance at the same or lower cost, then you call the technology as high technology. So it is really the how stringent the processing conditions are that decides how high the technology is. Nowadays, people are using the word deep technology. Instead of highness, people are talking about depth. It's just change of words. So in terms of this, sorry. Yeah. Semiconductor technology is a materials-oriented high technology. That means in semiconductor technology, you process material, you require stringent conditions, and the products are high reliability and performance at a reasonable price. Okay? Now, even though we can put satellite on the moon, you might be surprised to know that technology of making sewing needles, technology of making dry battery, technology of making semiconductor chips, all these are imported. So while we can send satellite on the moon, making a dry battery, making a sewing needle, and semiconductor chips, we import the technology. We might be making here. For semiconductor technology, even the chips were not being made here, and we are promising to make them. Some chips were made, but not on a very large scale. So now, at the end of my talk, you will get an answer for these questions. Why India has not been able to get into this area for so long? Okay? What is unique about this? Now, you might be interested to know that someone has remarked, if you want to know wealth of nations, simply count the number of semiconductor fabs that nation has. Simply count the number of semiconductor fabs that nation has. Then you can talk about the wealth of the nation. What is the reason? So it is a very capital intensive technology. Why is it so? The first requirement is that the material should be single crystal. Chips are made in single crystal semiconductor. Now, someone should answer for me, what is meaning of single crystal? Anyone? I'm sure you all have a lot of energy. You don't need a mic. I do not have your names. In fact, whenever I have a large class like this, I just utter names. So I was at IIT Madras. What I used to do is, I used to call out Subramaniam. Now, in such a large class, there will be some Subramaniams. Right. So I am now in Odisha. I'm assuming that many of you are Odia, right? So let me call out some nice sounding Odia name. Okay? Tell me one name that comes in Odia only and not anywhere else. Huh? Okay. Okay. Yeah, please. Yes. Sahu. Can Sahu stand up, please? Can Sahu stand up? I am sure there must be some Sahu here. Come on. Some Sahu. No, I'm sure you want me to go back with a good opinion about your place, right? So I'm sure there must be a Sahu here. Okay, let me change my question a little bit. How many of you here are Telugu speaking? Raise your hand. తెలుగు మాట్లాడే వాళ్ళు ఎంతమంది ఉన్నారు ఇక్కడ? గుడ్ గుడ్. సో ఎవరైనా ఇక్కడ మీరు స్టాండ్ అప్ ప్లీజ్. కెన్ యూ ప్లీజ్ యువర్ సెల్ఫ్, దట్స్ రైట్. స్టాండ్ అప్. యా టెల్ మీ. నో యా ప్లీజ్. yes. Let me move close to it. Yeah. Now look, you have to be serious. We have to be interactive and we have to be serious, but otherwise we go to sleep. Now please, let's please fall silent. Tell me, what is the meaning of single crystal? Single crystal. I know. She's saying, I said, those who are Telugu, please stand up. I know. That was the question. Okay. So I want answer to the question, what is the meaning of single crystal material? Please tell me. Yeah, sit down. If you don't know, sit down. Anyone, please answer to me, what is single crystal material? What is meaning of single crystal material? I am sure you know about it. You are just hesitating because a large number of people are standing here. Anyone? Yeah, do you know single crystal? See, okay, how many of you came across this word single crystal? Raise your hands. Those who have come across this word single crystal. 12th standard, all of you have written, you are all 12th standard people, science, yes. Yeah, good. Your hand going up, yeah. You attempt. Why don't you attempt? What is the meaning of single crystal? Yeah, what does it mean? You're almost close. You're almost close to the correct definition. Correct. You are right. Amorphous, single crystal. These are the various. So, what is the meaning of single crystal? This is very important. Anyone else? Anyone else? Yes. Good. I'm happy. Yes. You raised your hand. Good. Tell me. That extends. Single material. No. You're talking about element. No, that's not correct. Anyone? One more. Third person. At least 3 responses. I want 2 people have attempted. I'm happy. Anyone else? What is meaning of single crystal? Come on. Yes. You are close, but not exactly. Okay, so let me answer that for you. Yeah. See, now more people are attempting. Good.
Identical unit cell.
Identical unit again. Close, but not exactly. Yes. No, unbreakable. No. Okay. So the answer is a material is single crystal if it has a perfectly regular arrangement of atoms. A material is said to be single crystal if the arrangement of atoms there is very regular arrangement. Okay. Then it is called single crystal. In practice, the materials we have are most of the time not single crystal. The atoms will not be arranged in a very regular fashion. Amorphous materials, right? You take copper wire. It is not crystalline. It is amorphous. Okay. So how do you get single crystal material? That is where you have to invest a lot of money, lot of energy. Okay. So this is one area where in semiconductor technology, you have to invest a lot of money and energy. So you need perfect single crystal material. How many of you have heard the name transistors? Please raise your hand. Transistors. See, your computer science people doesn't mean you should not bother about anything else. Transistors, right? I see some hands going up. What does the transistor do? What does the transistor do? Yeah, so I'm getting an answer here. It amplifies, it helps you to amplify electrical signal. Now you can get that particular function only if you make it in a single crystal material. Next important condition, I'm talking about what are the processing conditions. We said in the previous slide that conditions are stringent. What are the stringent processing conditions for semiconductors, which are not there for glass, which are not there for steel? Okay, so perfect single crystal material, ultra clean environment. That is again linked to single crystal material that is required. Because if you are processing a single crystal material, no defect should enter this material when you are trying to make the device. How is it possible if for you not to have any defects? Your environment should be ultra clean. What does it mean? First, your air should be clean. Water which you use should be clean. Chemicals should be clean. Gases should be clean. So let's talk about how do you specify cleanliness of air. Anyone answer to this question? How do you specify cleanliness of air? What is the unit? When you say air is clean, what do you mean? What are you talking about when you are talking about air being clean? Huh? Correct. As someone has said here, AQI, air quality index. That's right. But what is the what goes into calculation of AQI? First important that comes to your mind, if air has to be clean. Normally if air is not clean, what will it contain? Okay, it will contain dust particles. So open air, if you're talking about open air, normal open air, it is said to be class 20,000 or class 1 million, in that range. What is the meaning? In 1 cubic meter, you have 20,000 to 1 million dust particles. Now, all of us are engineers. Are you happy with this description, or you need some more information? We need more information because we should talk about what is the size of the dust particle, because dust particles come in different size. So size of the dust particles less than a micron. If there are 20,000 dust particles of size less than a micron in 1 cubic meter, then that air is said to be class 20,000. So a clean air that is required for semiconductor processing has to be class 10 or class 100, class 10 or class 100. So that gives you an idea how much clean should your air be. A 20,000, class 20,000 air, you have to process and make it class 10. Okay, so again, lot of money and lot of energy required there. Clean water. How do you measure cleanness of water? Resistivity. A clean water will have very high resistivity or very low conductivity. Am I correct? A clean water. Why? Because water is clean if it doesn't have ions. If it has ions, conductivity will increase. Tap water, the conductivity is said to be 20 kilo ohm centimeter. Whereas for semiconductors, you need 20 mega ohm centimeter resistivity. Okay, so kilo ohm to mega ohm, about factor of 1000. Cleanliness. So that is where again you need energy and money. And you need all this 24/7. Gases. There are various grades of gases and chemicals. How many of you remember to have done some experiments in chemistry lab? How many of you have done, or once you have taken computer science, you have forgotten? How many of you remember having done experiments in chemistry lab? Raise your hands. No, not acceptable. How can you say that you have forgotten about chemistry? So if you remember, on the bottles, chemistry, chemical bottles, some grade is written. This chemical is some grade. Can you tell me what grade was written on the bottle? Any one of you remember? I am sure many of you were, or all of you were good students. So you did take a look at the bottle. You had curiosity. Apart from communication skill, you want to do well in academics at least, then you need to be curious. People don't have to tell you to be curious. Automatically, you need to be curious and you should be exploring, right? So laboratory grade. How many of you have seen this particular name? Laboratory grade chemical. Sulfuric acid, lab grade. Laboratory reagent, right? So that is the lowest reagent grade. Then you have analytical grade. Then you have semiconductor grade chemical. And today in semiconductor grade itself, you have an ultra clean grade called MOS grade, MOS grade. So you need those kind of chemicals. Again, that is where the money and energy and effort is required. So that is about cleanliness of environment. and then sophisticated equipment, right? So let's show you a room in which semiconductor devices are being processed, right? This is how it looks like. You can see this person is wearing gloves and a coat. Why do you think that person is wearing a coat? When do you wear coat? Sorry, radiation. Okay. What else? What other reasons? So you don't want chemical to fall on you. That is one reason, protect yourself. But in semiconductor area, not only that, you should not pollute. You should not pollute the air. That is what we are talking about. Ultra cleanliness is required. So you can't go into a semiconductor processing room just like that. And believe it or not, people have said, you take a technology from abroad. What is the meaning of take a technology from abroad? It means you buy the equipment and you buy the process. And you bring it here and you set it up. Same equipment. Come to India, set it up. Use the same process. Go through exactly the same steps. Your yield is much lower. Your yield. Now, how many of you know what is the meaning of yield? Yield means how many of the devices that are coming out are functional, right? What fraction of the devices are functional? Now that yield is lower. You know why? Because of human habits. Because of human habits. So it is that critical in semiconductor technology, right? Another thing, how do you maintain a clean environment in which you are processing? Apart from maintaining cleanliness of class here, you maintain positive pressure in a small region so that maybe this room is class 100, but that local area will be class 10. You maintain positive pressure. So air is always coming out of that region. Nothing is going in. It's always coming out. So that region remains clean. Any questions so far? Nobody raised your hand. Any questions so far? I'm happy that while some people are still chatting, there are many who are paying attention. So any questions so far? Okay, let's move on. What is the meaning of good technology? What is the meaning of good technology? These are the points. The technology is supposed to be good if it yields cheap products accessible to everyone. The first important criterion for calling a technology good is it has cheap products accessible to everyone. Consider a mobile phone. It's accessible to everyone. Why semiconductor technology is so unique? It gives products which are accessible to everyone, right? You don't have to be literate to be, you don't have, not only literate, you don't have to be really rich to possess a mobile phone. Compatible with man's need for creativity. You see the design of this room. A similar auditorium 50 years back would have looked very different. To take office space design today is very different, the look of an office room. One of the reasons for that is the presence of computers which have allowed you to come up with design, good designs, new aesthetic designs, new shapes, and new materials. Lowers consumption levels while improving standards of living. Lowers consumption levels. The energy that you spend for doing something reduces if you use semiconductor devices there. Okay? It is suitable for small scale application and it is inflation proof and recession proof. Now, I will not get into this because as I said, I want to explain to grandmothers and not to specialists. Okay, so I will leave these points here. So semiconductor technology summary is, semiconductor technology is a materials-oriented technology. It is high technology. It is a reasonably good technology. Okay? Now let's talk about products of technology. Unlike in many other technologies, the use of the products becomes progressively easy with advancement of the technology. Take automobile technology, example. Cycle is the simplest product. If you start with cycle as an automobile, then comes scooter, then car, then maybe aircraft, and then maybe spacecraft. As the technology advances, you need more and more training to use it. Everybody can ride a cycle, but you need a license to ride a scooter or a car. And you need further intense training if you want to ride a spacecraft or aircraft and so on. So in all other technologies, generally, when the technology advances, you need better skill to use the technology, product of the technology. Performance of new products can be predicted using relatively simple models. Is another another uniqueness of semiconductor technology. You can use simple models to understand how a device will work. You want to think of a new device, you can do it just using computers instead of actually making the device. That is why computer-aided design has so much role in semiconductor technology. In fact, so far, the Indians were mostly involved in only design, computer-aided design, not fabs. It is only recently that we have learnt about 1 lakh crore rupees investment in fab. Otherwise, what were the people doing in India? Mostly designing, using computers. So that has been possible because new products can be predicted using simple models. And what is the reason for this? The reason is again tied up to the first point that I said. Mostly semiconductor devices are made using single crystal material. So because you have regular arrangement of atoms, you want to predict the performance, starting with the atomic structure, behavior and all, you can easily predict how the device will perform. For amorphous materials, performance prediction is not that easy because arrangement of atoms is not regular. You can't predict very easily the behavior. Right. So this shows the development 100 years back. How was the calculator? It was like this. Today, it is like this. What could this calculator do? Maybe just some additions or multiplications. It was mechanical. This electronic. How many functions can it perform? It's all because of semiconductors, right? So now let's talk about training. What kind of training do you need? India needs a lot of trained manpower to man those labs and to develop the semiconductor technology from that level further, because you don't want to invest 1 lakh crores every 10 years, right? That will not be a intelligent or wise thing to do. So you have to develop yourself. Now, it so happens that the training required to contribute meaningfully in the area of semiconductors is a little intense. This is one of the problems with this technology. The two reasons for that are the theory of devices, semiconductor devices is abstract, and this entire area is highly interdisciplinary. So anyone who wants to contribute in the area of semiconductor technology cannot say, I'm not interested in chemistry, I'm not interested in metallurgy, right? I'll only do physics, I'll only sit in front of computers. No. Name anything, name any area. That area is required for semiconductor technology. In fact, when the 1 lakh crores were invested in making this, inaugurating these fabs and so on, it was also put out that which kind of manpower is required immediately. And believe it or not, they said we need chemical engineers. The maximum number of people required today to run those fabs, chemical engineers, right? Not even electronic engineers. So that is the nature of this technology. It is highly interdisciplinary. And why is the theory abstract? Because you have to start from the atomic structure. You must understand the atomic structure. What kind of theory is required to understand the atomic structure and behavior of atoms? Anyone can tell me this answer? I'm sure you should be able to give. You want to understand behavior of atoms or behavior of a collection of atoms. What is the theory that is required? There is some name for it. Anyone? Yes, anyone here? Just all of you have done. How many of you had to do physics course in the first semester here? Raise your hand. How many of you had to do a physics course? I see some hands going up. So tell me, now I have given you a hint. What is the theory? There is a name. I'm just talking about the name. All of you know it. If I tell you, then you'll say, okay, this is what it was. You have learned it in even school days. You want to explain atomic the spectrum. What is it that helps you to black body radiation? What theory is required to explain that? These are some things you can't forget. So, theory of quantum mechanics. You need to understand quantum mechanics if you want to predict behavior of semiconductor devices. There's one example of abstract theory. I'll tell you some anecdotes. You can make things interesting by telling stories, right? So, a very well-known expert of quantum mechanics was teaching a class. After about 15 classes, one student got up and said, "Sir, I want to tell you I don't understand anything. I have not understood anything what you have taught in the last 15 classes." Then this person remarked, and that is very important. He said, "Young man, you never truly understand quantum mechanics. Young man, you never truly understand quantum mechanics. You only get used to it. You only get used to it." That is the nature of when a theory is abstract, it is not very easy to understand. What we do is we get used to it. So any of you, if you are feeling difficulty in understanding something because it is abstract, please remember this quotation. That will reduce your anxiety and difficulty, because you don't really have to understand. First you get used to it, right? And then maybe in due course you will understand. So that is as far as the training of semiconductor technology is concerned. Now we are coming towards the last part of my talk. Evolution of semiconductor. How has it evolved? The story of semiconductor technology is very interesting. The first interesting thing about it is science first, empiricism next. What does it mean? Glass. People have been working with glass for thousands of years. People have been working with steel for thousands of years. It's only in the last 100 years we are looking at steel, glass, and everything from the point of view of molecular structure, compounds, and so on. It's not as though for thousands of years people are looking at it like that. Because of a changed perspective, definitely in the last 100 years, the materials area has grown faster, no doubt. But people have been working. So empiricism means trial and error, developing by trial and error, right? So glass, steel, these materials, several other materials have been developed by trial and error, technology of that. But that is, semiconductor is not like that. It is not as though people were working with semiconductor thousands of years. No. Science came first. People were studying materials. In 1911, the scientists coined the word semiconductors for a class of materials which were behaving very uniquely, very differently than conductors and insulators. Okay? And it is after 1911, suddenly people thought, oh, semiconductors have such nice properties. Why can't we make some devices using them? That is the meaning of science first. So first, its science was understood to some level of this material. Then people started thinking about its use. The next important point is all these three kinds of people have contributed to its development. So next slide, I'm going to show you the names of people and events which have contributed to the development. And I'm also going to tell you the difference between scientists, engineers, and inventors. Do you think these three words mean the same? How many of you feel these three words mean the same? A scientist, an engineer, and an inventor. These three are same. If not, somebody should be telling me what is the difference between a scientist and engineer. How many of you feel you are scientists? Raise your hand. How many of you feel you are scientists? Nobody's raising. How many of you feel you are engineers? How many of you feel you are engineers? Some hands are going up. Then what about others? Please tell me. There are many hands which have not gone up. See here. You tell me. You are not raised your hand. Maybe I should come closer. Yes, you tell me. You are not a scientist. You are not an engineer. What are you? Huh? Doesn't matter. That's fine. Okay. She's saying that she's on the way to become an engineer. She's not an engineer yet. Fine. Let's talk in terms of that. How many of you are on the way to becoming a scientist? Raise your hand. Okay. Somebody raised very confidently, right? How many of you are on the way to becoming an engineer? Raise your hands. More hands are going up. How many of you are on the way to become inventors? That is really good. Can you stand up, please? Tell me, what is the invention? What is the meaning of invention? I will tell you loudly what he is saying. Right.
Invention is something to nation development.
Something to nation development. That is very broad, right? Even engineers can contribute to nation development. Scientists can contribute to nation development. A guy, stand up. Sit down, sit down. Which is not exist, you invent something. Okay, good point. Good point. Something new, right? So let us look at this a little more clearly. Let's define these three. Okay? So the activity of science. Activity of science. We are talking about what is the motivation for a person to do the activity and how does the person do the activity. What is the nature of the activity? What is the motivation for the activity? We'll try to distinguish between scientist, engineer, inventor from this point of view. Motivation. Science is primarily driven by curiosity. Primarily driven by curiosity, right? You take a small baby and leave the baby in the room. You will find naturally going towards something, opening up something, touching something, right? Smelling something, so on. You're not doing it right now. Unfortunately, your curiosity has reduced for some reason. We can talk about that, why it has reduced, but we have limited time. So baby is curious, right? If an activity of trying to understand the world driven by curiosity, that is called science. Okay. Ultimate goal of science is publication of new knowledge, frequently mathematical, which establishes new links and patterns of understanding and integrates seemingly unrelated observations and phenomena into a grand pattern. That is what is the nature of the activity. So planets are revolving around the sun. Apple is falling on your head. One motion is elliptical, circular, whatever you may call it. Other motion is straight line. That is how it appears. They look very different. They appear to be different, but both are governed by the same theory. That is theory of gravitation. This is what is meant by linking seemingly unrelated observations into a grand pattern. That is what a scientist does. Moment a pattern has been obtained by the scientist is happy. Scientist doesn't bother whether that knowledge is going to be useful for society or not. That is not the concern. Just the fact that I have been able to relate something that appeared to be unrelated, that itself gives sufficient excitement. That is what is a scientist. Okay. Now, engineering. What is engineering? Ultimate goal of engineering is products and processes aimed at practical ends. These should be safe, eco-friendly, efficient, economical, reliable, and easy to fabricate. That is the goal of an engineer. Engineering requires a reasonable knowledge of scientific principles, mathematics, logic, and economics, rather than grasp of nuances or detail. So, an engineer doesn't have to understand physics or mathematics, chemistry to same depth as a scientist, but must be able to use these principles for developing products, processes, and so on. So engineer is very practical. Engineer does things which are useful to the society. Okay? Doesn't mean engineer doesn't have curiosity, but curiosity plus whether something is going to be useful. That is very important. You can call yourself an engineer only if you have that kind of a flavor. Okay? Now, it requires a knowledge of scientific principles, as mentioned here, mathematics and so on, rather than fine details. Another very, very important thing for an engineer, an ability to identify variables that can be ignored in a given situation based on hands-on experience and intuition. An engineer should be able to approximate. Given a complex situation, engineer should be able to tell, I think so many parameters are there, but for my purpose, to do my job, I think I need to consider only these few. I can ignore the others. An engineer should be able to tell this. This is the engineering skill. Okay? The formal education of engineers has a strong practical flavor as compared to that of scientists and includes economics. Now, let's talk about invention. The ultimate goal of the activity of invention is combining previously unassociated elements in a practically useful manner, which is non-obvious to one skilled in the art. Whatever that student said, something new. It is not only new, it is useful. It's a combination of newness and utility. Both are important for invention. Okay? Now, there are various strategies for invention. Try new combinations in search for a new result. Identify genuine need and devise an effective novel solution. Identifying the need requires more insight and skill than devising a solution. So if you all want to do invention, this is what you must develop. Ability to identify the need. How many of you have read something about Einstein, something about Edison? Raise your hand. How many of you have read something about Edison? Come on. I would like to have at least one hand going up. How many of you read something about Edison, I'm saying? Yes, nice. Yes, I see one hand going up. Tell me, what have you read? Yeah. Correct. You know about that, right? Have you read more about him? Anything more? If you're not read, you say no, no problem. Anyone like that? He said Thomas Alva Edison invented electric bulb. He has read about it. Anything more about Edison? How he used to work? He was working with Nikola Tesla. Good point. Good point. Yeah. Anyone? Yeah. Tell. So all of you have read. You're not saying, but you have read. Very important point he said that he failed 10,000 times before actually getting a bulb. Okay. Now the point is, I'm trying to connect it to what the points written there. It seems Edison in his early days would think of something new, and then he would go around trying to convince people to use that new device. So he would think of a new device, and then he would go around telling, hey, why don't you buy this device? Okay. And then he found it very difficult to convince people. So the famous Edison that we know of, became famous only after he changed the strategy. He then realized what he should do is first he should find out what do people want. What are people's needs? Then you think of a new way of fulfilling the need. And once he changed the strategy, he became very prolific, and it is only after that he became famous. So this is very important. You all want to become inventors. What is the important thing? You must be able to identify the need. You must be able to identify the need. Okay. So let's go ahead. Most invention is done by scientists and engineers, but all scientists and engineers are not necessarily inventors. This is because utility is a dominating criterion in inventions, while scientists often eschew practical considerations as mundane and less than pure. So you have people who are great mathematicians. They said, look, I will not do anything that is useful. I will only do something if it appeals to my sense of beauty. I work only because I find some pattern, some equation beautiful. I don't care if something is useful. Now, if you have that kind of an attitude, you can't be an inventor, right? You can be a scientist, mathematician. Now, another interesting thing, Edison, without a grasp of mathematics beyond arithmetic, lacked the tools of a scientist as well as a motivation. But he was a formidable engineer and great inventor. So this is important. In our own education system, we should check, are we able to identify people like that? Or we are only interested in giving marks to students who write good answers in papers, right? Our society, obviously there are scientists, there are inventors, there are engineers. Are we able to identify the abilities? These are some natural abilities, right? So I leave it to you to judge how many of you. Now, okay, let me ask that question. Now, after this discussion, how many of you feel you are on the way to become a scientist? The scientist's career is probably suited for you, primarily driven by curiosity. How many of you feel you are on the way to becoming scientists? Raise your hand. Nobody's raised. I see one hand going up. Good, happy. So what do you want to become? Let him tell. What do you want to become? You said scientist. So what would you like to do after your education? Shout out a little. Yes, tell me. What do you want to become? You want to? You want to discover something for society. Right. By using artificial intelligence. I'm trying to tell loudly what you're saying. Yeah. So he wants to change the lifestyle of people using artificial intelligence by discovering something new. Okay. How many of you are on the way to becoming engineers? How many of you are on the way to become engineers? Hesitantly. Come on. All the others who have not raised their hand. Come on. Yeah, you tell me. What do you want to become?
Actually, I want to become an inventor of this.
How many of you want to become engineers? Please tell. Yes. You tell. What kind of job you want to do? Automobile. Right. Yes. Computer vision. Now, can we fall silent for a while at least? Can we all become silent for a while? Yes. Thank you. Okay. So now, let me check how much time do have I. What is the time now? Someone tell me, please. My watch is there. 4:30. Okay. So 5 minutes I have. Right. Now, this shows the evolution of technology. Another important thing all of us should know, whether we are doing engineering, science, anything, right? Some of these things are not a part of syllabus. Some of these things are not part of syllabus, unfortunately. But these are the things that make you a better academician, right? These are important things. Somewhere or the other, this should be taught. So how has semiconductor technology evolved? Some events, and who are the type of people who have contributed. Okay, again, can I have silence? Excuse me, can I have silence? Letter S means scientist. Letter I means inventor. Okay, so here you don't see E. The next slide you will see E. E means engineer. So now let's look at how fields have evolved. If you take the field of solid state, that is working with solid materials, that is called solid state. What are the properties which were discovered in sequence? Thermoelectric property, intrinsic property, photovoltaic effect, photoconductivity, and so on. You see, all these are scientists. So the field of solid state developed primarily because of scientists. You just see one inventor here somewhere around 1860. Otherwise, it's all scientists. But look at field of communications. Field of communications. You will see alternate scientist, inventor, scientist, inventor, scientist, inventor, right? So magnetism from electricity and vice versa, Oersted and Faraday, scientists. Once this knowledge was developed by the scientists, in came an inventor. How to use the knowledge for society? Telegraph, Morse. Then Maxwell came up with the theory of electromagnetism. Thereafter, Alexander Graham Bell developed the telephone. Experimental proof of electromagnetic waves. Heinrich Hertz, he showed that electromagnetic waves actually exist. Immediately thereafter, inventors, Bose from India and Marconi, they developed wireless communication radio. How to communicate not with wires, without wires. So this is how scientists develop knowledge. Inventors use the knowledge to improve the level of standard of living. Okay? So technology develops because of presence of these different types of people. If you have only one type of person, it won't work. You need collaboration among all these types. Let's go to the next slide, which is the last slide in evolution. How did the communications evolve? So here you have inventor, engineer, inventor, engineer, engineer, inventor. This slide contains all engineers and inventors in the field of communications and the name of the scientist as well as the event. Vacuum tube, diode and triode, positive feedback, sine wave oscillator, negative feedback, frequency modulation, pulse code modulation, information theory. All these are engineers. So it is important for all of us to read some stories about these kinds of people. Scientists, how did they work? Engineers, how did they work? Then only we can figure out whether we are scientists or we are engineers or we are inventors. You want to become a good inventor, it is good to study biographies. Now look at solid state here. The word semiconductor was coined in 1910. 1920, quantum mechanics was developed by these scientists. And then came an inventor, name is Lilienfeld. He proposed the idea of a semiconductor triode. Here you can see vacuum tube triode, 1910. Around 1925, semiconductor triode. So the inventor said, because the field of semiconductor has developed so much, can I use semiconductor instead of a vacuum tube to make an amplifier, to make a three-terminal device? So he proposed an idea, drew a sketch configuration in a paper. That was the patent. And thereafter, a lot of people started working on this device, but they took more than 25 years until 1950 to actually make a three-terminal device that amplified. And that was the bipolar junction transistor. So these are interesting people who can be regarded as scientist, engineer, and inventor at the same time. Very rare breed. People who can be regarded as scientist, engineer, inventor. All three put together. And then came in 1960 the invention of the integrated circuit by engineers or inventors, Noyce and Kelby. How many of you know the name of the engineer who has been given Nobel Prize in Physics? How many of you know the name of an engineer who was given Nobel Prize in Physics? Anyone, please raise your hand. Name of an engineer who was given Nobel Prize in Physics. I see some people standing. Can you kindly, can I know what are you doing? What is being done? Yeah. What are you doing with those papers? So being taking attendance means being attentive. I am going to, your teachers are going to set a question on this 1 hour talk, and they will check how many of you are able to answer questions. Right? Okay. So Jack Kilby is the only engineer who has been given Nobel Prize in physics. Only engineer who has been given Nobel Prize in physics for his invention of integrated circuit. Why? Because that invention of integrated circuit has revolutionized the world. Chip. Integrated circuit is nothing but the chip. The idea was so revolutionary that a lot of physicists tried to understand the phenomena which are present in an integrated circuit. And as that circuit became more and more dense and devices became very small, a lot of interesting physics emerged. So because his invention gave rise to so much of studies in deep physics, he was given a Nobel Prize in physics. Okay? Right. Okay, so here is a summary of what we discussed. Semiconductor technology is a materials-oriented, reasonably good, high technology. Why is it high technology? Because it requires stringent processing conditions. Single crystal material, ultra clean water, gases, chemicals, and sophisticated equipment. Its products are easy to use, reliable, and high performing. Its training involves abstract theory and interdisciplinary topics. You want to develop trained manpower for this 1 lakh crore fabs. You need people with this background. And it has evolved due to the activities of 3 different kinds of people, namely scientists, engineers, and inventors. Okay? So with that, I'll stop. And no, before clapping, wait. Before clapping, what do you think I expect? Huh? Very good. So at least I'm happy you're attentive. So tell me, at least ask me one question. Ask me one question. Oh, let's be serious. Question on the topic. Any one question, right? All of you are creating an image of your institution. Please understand. I know all of you, you have doubts and you have questions. Many of you were looking at me, so I assume that you were attentive. I'm sure you can ask me some question. Yeah. Yeah. Please fall silent so that at least towards the end, you can all be silent for few seconds so that we can hear him. Okay? Yes, please go ahead. You are asking me whether what? Correct. So discovery and invention, right? What is the difference? Something exists already and you have discovered. For example, bipolar junction transistor. I think from here I cannot go back to the previous slide. Bipolar junction transistor is regarded as a discovery. Which one? But we have to see in what form it existed. Right? I am not knowledgeable to answer that question. Right? We have to examine it deeply. I'm saying discovery is something that exists and you have found. Invention is you have thought of it in the mind and then you have realized it. Right? So among transistors, you want to remember bipolar junction transistor is a discovery, MOSFET is an invention. Okay. Fine. I think with that, I stop. Thank you all for attention.
Thank you, sir, for your valuable and interactive session. It could have immensely benefited our fellow students. It is with great honor and pleasure that we extend our deepest gratitude for graciously sharing your wisdom, experience, and vision with us. Your dedication to excellence, tireless pursuit of knowledge, and unwavering commitment to positive change serve as a beacon of inspiration for us all. Now I request our General Chair, Professor Dr. L.M. Patnaik, sir, to felicitate our honorable chief guest, Professor Shreepad Karmalkar, sir, Director, IIT Bhubaneswar. And to the wealth of knowledge shared with our students as we proudly unveil the release of our conference proceedings. Delve into the insights, discussion, and groundbreaking research presented by our esteemed guests, now collected in a comprehensive collection for your future reference. Let us begin to teach you 2024. Now, it is time for our Deputy Dean of Computational Science to address the vote of thanks for the session. Thank you. Thank you. Esteemed Chief Guest Professor Rammohan Singh, IIT Bhubaneswar, General and student friends. Difference between a scientist, engineer, and inventor. Suddenly, I can decide about skills and so I will is an Indian. We are so it also the knowledge, the skill, goes in a level. Academic special thanks to Professor Vice Chancellor and guidance. Since I have served this conference program in Udgata, suspending the conference program and also relevant education for the post-conference analysis.
as an instrumental to save the success of the conference. And commitment for execution of this conference. And to making this event a successful one. Exchange sustain running and execution and ensuring the success of the company. Last but not Thank you.